Okay, here is target 3 and 4, bookwork number 7. So it says in exercise 7, identify the segment bisector of JK, segment JK, then find the distance between J and M. So I know that in order for something to be a segment bisector, it has to hit right at the midpoint. And in order for something to be a midpoint, it has to split a segment into two equal parts. Well, I know that JM and MK are two congruent segments because of those little tick marks. I know that that means that those are equal in length. So I know that M is the midpoint, that's for sure. Well, in order for something to be a segment bisector, it has to either hit a midpoint or be a midpoint. Well, I know that M is our midpoint, so I know that point M is my segment bisector. And then it wants us to find the distance between J and M. Okay, well, I know that I need to find x. That's going to be my first step because I need to find the actual distance. I can't just say that 7x plus 5 is jm. I need an actual number for my answer. So in order to do this, if I know that jm and mk are two congruent segments, I'm going to write that out. Jm is actually equivalent to mk. It's equal to mk. I'm just going to put a little equal sign in between there. I can substitute in my expressions. So I know that Jm is 7x plus 5, and Mk is represented by 8x. So from here, I'm actually just going to solve for x. I'm going to subtract 7x from my left and get it over to my right to keep my x's positive. And I can say that 5 is equal to x. Now, I'm not really done here. The last step I need, since it asked me for the distance between j and m, I'm going to take the value I found for x and substitute it in right here for this x value. So off to the side here, I'm going to do that. I have 7 times my x value that I found, which was 5, plus 5. I know that 7 times 5 gives me 35. 35 plus 5 will give me 40. That's the distance between j and m.